Hey, what's going on, guys? Kamakenzi here. In this video we're gonna see how the almighty global variables can help us with the automated data extraction. So the traditional way to extract the data from the website, to crawl through the website, is using the direct HTTP, either GET or POST request, depending whether you're scraping the data from the website itself or from the APIs. But with sites like LinkedIn, for instance, the level of anti-scraping measures is so big that it's next to impossible to actually get a single piece of data from those sites, because nowadays data is almost like equals money, and it's most likely it's already illegal, I believe, like violating the terms of usage of the services might lead you into the trouble. So I'm highly discouraging you guys from scraping LinkedIn ever. And if after watching this video someone would ask me to scrape LinkedIn using the method that I'm going to be introducing here in this video, then the answer is no, I will never ever be doing that. Okay, so now we can actually dive into the technical details. So the method that I'm about to be describing in this video is the following. So if we go to the browser console, and if you just create a global variable called HTML string, which is going to be equal to document.body.outer.html, then here we have 276 kilobytes of the pure HTML snapshot data containing whatever we have here on this page. We actually, sorry, just forgot to, I want to go for a specific search here. So let's say we're looking for Python developers. So I want to see all people results, all results for people, right? I click somewhere, nope. Yeah, here it is. So I want to see all people results here, all right? And let's just make this step one more time. So now I want to copy this. And here, just create a new document called response.html, and we open this. And here, just paste whatever we have extracted from the browser and save and close to make sure that my code editor doesn't hang. And here, if we update the page, we get no styles, no fancy things, but we have the links to those guys we're interested in. So, which means that later on we can extract this kind of links using beautiful soup or scrapey selectors, for instance, or whatever. So that is going to be covered later on within the video, but for now we want to focus on the crawling itself and extracting the data. So yeah, we got this Python developer. So some of the guys we're looking for. Okay. So now if we go to the next page here, for instance, go into the next page, and here if I just say HTML string plus equals document body, we already have more data. So if I copy this data here, and am I within this? No, I just want to go to response again. It's gonna be incredibly laggy, I'm sorry for that, but just show you this once. So I want to delete this, paste, and save. So now we'll have up to 2 pages being stored into a single HTML document. So I don't need this anymore. And now if we update this one, then you see like, oh well, this LinkedIn logo claims the beginning of the new page, and now here down below we'll have, after all the results are done, we have another one. So here the new page basically starts, and we can use this entire HTML document, which is not really HTML document, but just a bunch of HTML tags with links. We can use it to extract the data for every single developer we're looking for. So our goal is to automatically crawl through all of the pages in the browser console here, right? And that's the reason how, that's the method of how we can actually kind of go for this automated data extraction. So the next thing, I'm looking for this next button or link or whatever it is. It should be button here, yes, the button. So we can search it by this area label area label equals to next. So the way how we can do that, so we go to console. I can simply say document query selector, and I'm looking for area label equals to next, like this. And indeed, we do have this button. So see, like, it gets highlighted here. So if we now say here .click, then for instance, yeah, here we go. We just automatically navigated to the next page. But it's not that easy and not so fast really, because you also need to mimic the scroll down to the bottom of the page, for otherwise it's not going to be working in the automated mode. So we need to say something like say we are right over in here. In this case, we need to say like window. We need to say window dot scroll by 0 on X and on Y, let's say 5,000, like this. And we just go to the very bottom, and then if we wait for a little bit until everything just gets settled down there, so we can't do this extractor selection directly, we need to use the set timeout to give it a little bit of a time to mimic the user experience, and then we can mimic this click next, and it's gonna be working. So every time we do that, we have this HTML string being populated, and eventually when we loop over the desired amount of pages we want, we can then just grab this entire HTML document, store it into the file, and then extract the links, and we're done. So from now on, let's actually start writing some code here. So here we're gonna be making some automated in-browser web crawling. The very first thing to consider, so we want to define our global HTML snapshot, HTML string snapshot, and here I define HTML string, which is going to be equal to document dot body dot outer HTML, just like we did already. Then the number of pages to crawl, we'll need this later on, so let's say pages is equal to 10. So let's say we want to crawl through 10 pages, so fair enough. All right, and now let's create a routine to extract the data from the website, from the page. So here is the function, let's call it extract data. And well, probably the first thing, so want to print the page we're currently crawling through, because it's not gonna be seen that nicely. So I can simply say console.log and let's say current page and plus the page. Yeah, let's make it just like page and page 0, and here we can say just page +1. I believe this is enough. Or no, we can even say like, so here we want to increment page, so page ++. So far so good. Okay, and now the next thing, we want to scroll window to the bottom. So here I just say window dot scroll by, so 0 for X, 5,000 for Y. So after this, we're going to be the very bottom of the page, which is good. And then we want to click. Let's say the rest of actions are done in the background. Hence this, I'm using the set timeout function here. So here we take the function itself, and the timeout would be like 5 seconds, for instance. That should be fairly enough. So here, the very first thing is to append HTML snapshot from the next page. Well, from the current page, actually, from the current page. So here I can simply say HTML string plus equals, actually here, we don't even need this. We can simply say like so, right? Append this. Then we want to extract next button selector, and for this reason I will use this query selector. So copy this one, and here I just say next button is equal to this one, and then we want to mimic a click on the next button. Alright, so here I just say next button click. Right, so here we should already be at the state where we just clicked the next button, and then we want to repeat things for the rest of pages. So probably before repeating things for the rest of pages, I just want to make sure that it works for a single page. So currently, if I grab this code and just want to restart everything here. So what should happen now? What should happen now? Here it should just find the selector and extract the data from the first page and click once on the next page. So the single iteration of what we're supposed to be doing with the entire script. So let's quickly check that out to make sure it works. So here, if I now say extract data to run the script, so currently we are at the page 1, but after I hit enter here, it should go to the page 2. So it scrolls down, and then it should go to the page 2. And it does. Yes, I didn't click anything. I swear it did it on its own after 5 minutes. So now you see like it's currently at the page 2. So it's there. So exactly what we're expecting for. Okay, so now I just restart this from scratch again. All right. And now the most interesting thing comes here. So here I use another set timeout function. And I also want this one to be in a 5 seconds. It probably maybe less, but that's something I've been testing, which works nicely. So here, if I have this function, well, no, I actually don't even need any function here. Here I just say extract data. And you might be wondering that this calls the extract data recursively. Well, not exactly. It would be recursive if I call it like this. So here it just kind of runs this in a loop in the background again. So this is like as if I've been clicking, if I've been calling extract data manually in the console again, then again. That's kind of what it mimics. What it mimics, sort of. Okay. So if I now did everything properly, then in theory it should already be working. So let's check that out. So bring the code in, and just to make sure that we are currently at the page number 1. Okay, one last thing I forgot to do. So now it's gonna be infinite. So I can say if page is less equal than 10. So let's say scroll through 10 pages. So yeah, if page is less equals than 10, then do this step. We do increment our page, so when the page is going to be 10, well, it's going to be 11, then it's no longer goes here and just drops. So yeah, so probably just let me just overwrite this thing, and now if I go to extract data, I hold my breath. If I did everything properly, it now should be crawling through all the pages, meanwhile extracting data, meanwhile printing the page. So now in 5 minutes, it should, yeah, now you see like it goes here to the next page. Here in my hands, I'm not touching anything again. So it goes to current page 2. You see like just goes through another page. All right, so here we go. So there are two delays. The first delay before it clicks, so it just scrolls down, then waits for 5 seconds, then it clicks the next button, and then it waits for 5 seconds until it's being loaded, and then again it scrolls down, then again it waits for 5 seconds, and that's it. And that's the way how we extract all of these Python developers from LinkedIn. Okay, so we still need to wait a little bit until it goes to the page number 10. And again, from the LinkedIn website perspective, all we do now is like we just legally navigating, surfing through the website. So the delays might be randomized as well. So I don't know, probably it might drop, and it probably might be treated as an automated script at some point. But we're not doing this from the bare metal, from the bare Python. So we let the browser fetch all the data we need. So all the API calls are done automatically. That's kind of it. And now we should actually stop at the page 10. And there already the entire data, which is available within the global HTML string variable. So long live the global variables. May the global variables prevail on Earth, right? So that's definitely what should be. Well, I'm not sure. So why it goes through the page 11? Yeah, probably should already drop here, and I really hope so. Yeah, it just prints one more time, but it's not going any longer. Okay, so that's fair. Yeah, it didn't even scroll down. So yeah, this is okay. So it stops. It's actually, yeah, that just shouldn't be printing this, but doesn't matter. So now let's inspect this HTML string, and now it should be a huge one. So we have 3 megabytes of data now. So we can copy this, and let me just delete this one. And I just create a new one, just would be faster. So response.html, and I paste the data in, and it takes ages because it's a single line, and the input buffer for my code editor is going crazy after. But okay, so save and try to close this. You don't see it's malformed, it's actually okay there. Just takes ages to save, but yeah, just because this is the single line doesn't work that nicely, but it doesn't matter really. We can still kind of work nicely with this file from now on, right? So yeah, come on. All right, so we got it. Great. So from now on, well, the very first experiment to consider, we can just try to call our response. And again, if you notice this LinkedIn logo, it claims the beginning of the new page that has been appended to the previously extracted ones. So there should be somewhere in here. Yeah, we got another page and so on. So we have up to 10 pages, and all the developers are right over in there. So it's fairly enough. Yeah, it's another page and so on. So I hope you get the idea. And now we actually, so since this is already a valid HTML, extractable HTML sort of a thing, we can just inspect the element. And I will now quickly go for a Python console for interactive Python shell session here. I just want to find, yeah, so for instance, a class AppAware links. So for instance, like this ones. Yeah. All right. So the very last but not least is the following. So let's open the terminal. Let's go for browser here as well. And here I'm going for Python 3. All right, so I want to say from scrapy.selector import selector just to parse this HTML. All right, and let's say I call it make a response object equals to selector. Okay, so first we need to load the HTML. So HTML is going to be equal to open and res.html and .read. And if I have a look at this, we got this whole lot of int of data. So now we can say response equals to selector, and we say text equals to HTML. So from now on, we have the parsed HTML, this res, like response and scrapey when you get back from the request. And now we can already use, so let's create this links basically, which is equal to response.css, and we're looking for the a tag. And what in particular are we looking for? So class equals to app aware link, for instance, app aware link. We're looking for the attribute of hrefs, and we want to get all. Right, so here we go, and here are our links. Okay, so from now on, so yeah, we got this links already. So from now on, let's actually try to write this to the file. So I can say open and links.txt. I want to write bytes dot write, and here I want to join with a new line all the links. And then since it has more than we need, we're gonna be filtering links a little bit later on. So here are the bytes written, and here is the links.txt file. So we got all our developers, but well, here actually not all of the links are exactly what we're looking for. So far we have more than 500, but it's like we have this like search, which is not exactly what we want. Well, we're gonna go for more precise selector considerations, but generally, yeah, we have a little bit of a duplication. So probably we can go for creating a set out of the list, but for now, I think so. I just want just to give an idea. The problem here is the reason why we need a little bit of a filtering, because not all the developers, not all the links relate to the Python developers. Some of them might not be. Some of them might not be the developers, but some random links. Well, here indeed we have the Python developer, which is good. All right. And what about this? What about this? So not all the links might be that great. And of course, I understand that just the bare links doesn't help much. But anyway, yeah. For instance, this one is not. So it's like it's just some random guy that I'm not sure why it goes here. So one of the way of how to go for it. So let's filter. So make sure it has this in. So to avoid the links like this, for instance. So we definitely don't want a link like this. So just to give an idea. So this is the link that we don't really want to have in our list. So it just goes again like back for the result, the search results, which is available here as well. But that's definitely. And it's not even Python developers, it's just the recruiters for some reason. I'm not sure why it comes here. But there is a quite handy way quite easy way how we can filter this. So I'm using the list comprehension here. So let's say L for L in links, and then if in, which makes sure that we are only looking for not for the search results but for people, in L, and also we're looking for this dash in the link itself. So all right, so that messed up the syntax. All right, so okay, let's go step by step. Okay, so now I see like it's already twice less, which is good. And also, can I say here and dash in L? Okay, so now it's even less, which is good. So now if we just go here, still, so now it's hopefully more or less valid links. But still we have this duplication. So to get rid of those duplications, we can convert this list to a set. So here if I say set and like this, so now much less results, but yeah, now we no longer have the duplications. And now all of these guys are most likely to be exactly Python developers. So just check some random one to make sure this is so, hopefully. Yes, Python developer, he is. So far so good. So yeah guys, this is pretty much all about it from my side. So we came up, well, it's only 95 links, but these are the real ones from 10 pages, which is exactly the number it should be. And you see like the code actually to extract these links is quite trivial as well. So once we have this response.html, which aggregates all the pages we've been automatically crawling through within the browser, using this tiny little piece of code, we can then easily extract them using the powerful parsers that allow us to get whatever data we need. And obviously, it's not about the LinkedIn, but about some different sites. This exact method can be applied as well. So you can just crawl through those pages that you can crawl from within Python, for instance. So you can just grab this HTML data. It takes kind of a lot of space to save that, but you can then easily parse that offline, extract whatever you need, manage it nicely, and be happy with that. So this is it from my side. Thanks for watching. Until next time, and take care.